Rob, we're talking about ThreatLocker and network control. Now, network control has been around for a very, very long time. I'm going to even say it's been around longer than the concept of cybersecurity in general. Give me the basics of network control and how ThreatLocker is attacking it.
That's a very bold statement, David. Very bold statement. But yeah, network control is, look, firewalls are probably the most basic form of network control. Problem with firewalls is they tend to be pretty static.
Yes.
So basically you set up a set of rules and basically connections are allowed or denied according to those rules. But that doesn't really work when you're talking about a dynamic environment inside your network, basically. And again, one of the big problems with firewalls is people tend to have firewalls at the perimeter and then assume everything inside is okay.
Yeah, that's a classic assumption. By the way, our audience knows that's not the case. The classic metaphor of the candy bar of a hard out shell chewy in the inside, and they know a lot of problems can happen if you get inside.
Yeah, absolutely. And again, there's all sorts of means of doing that. It could be something like a remote access application you use, or a team viewer, or an AnyDesk. It could be vulnerabilities in the VPN. I mean, we've seen lots of organizations have been affected by. I mean, there seems to be a CVE almost every week for some of the major firewalls and VPN solutions. But anyway, leaving that aside, again, going back to what we spoke about before, probably the first and most important thing about networking is to be able to see what's going on. Show me what's happening. I need to be able to see.
Visibility. This is a major tenet of ThreatLocker is visibility.
Absolutely. So you can basically see all network activity within this environment over this period of time. So that's a really good place to start. So I can see what network activity looks like. So now I can start looking at controlling this network activity. So what we can do is we can create network control policies. So network control is effectively an endpoint firewall for us. It's going to take over from Windows Firewall. It's going to replace the Windows Firewall. But we can create a set of policies to allow what needs to happen, and much like everything else we do, block everything else by default. So I have a couple of policies created here. If we have a look at our workstations are a really good example, okay? Because workstations, generally speaking, do not need inbound network connections. Okay, we did a speaking engagement recently where we were talking alongside one of the major EDR vendors, and they mentioned a terrifyingly short amount of time before lateral movement within a network is possible. They mentioned that it can take 2 hours, but in some cases it's minutes to get from one machine to another within a network. And if you implement these controls, then that just doesn't happen. So I've got a set of policies here. You can also use it for blocking outbound connections. So I don't want anything in my environment to access Mega. And there's no good reason for anything to access Mega. It can be used by bad guys. I don't want people to be able to access it. But equally, I can block things like Dropbox. The beauty about network control is not only is it going to block web activity to Dropbox, it's also going to block, for example, PowerShell from accessing Dropbox, or anything else, even the Dropbox application from accessing Dropbox. So I can put in controls like that in place. So as I said, workstations are pretty much a no-brainer and are a really good place to start. Now, servers can get a little bit more complicated than that. So for example, I've only got one server in my environment here. I've allowed things like DNS. I've allowed things like Active Directory because it's an AD server. As you can see, the policies themselves are very simple. It's basically just, these are the things that I want to allow. This is where it gets really interesting, is when we start talking about objects. And this is why what we're talking about is dynamic access control. It's not static access control. It's not these ports are open on this server, and once we've done that, everything on the network can connect to these ports. We're going to be specific. We're going to say, I only want things, in this case, running ThreatLocker within my environment to be able to connect to this port on this server. So if a device is running ThreatLocker, it's protected, we know about it, it's going to be allowed to connect. If it's not, it won't. So that's what's going to protect you against things like compromised VPNs. So it doesn't matter if your VPN's been compromised. Even if you've got it synced with your AD, that user still isn't going to be able to connect to the server because that device fundamentally is not going to be running ThreatLocker. Now, I'll show you what this looks like in practice. I mean, it's really simple. Sure. For example, I want to terminal services, MSTSC, to my server from my machine. Whoops. So connect, can't connect because we don't have a policy in place to allow this. So what I'm going to do is I'm going to create and show you how easy it is to create a policy. I want to permit Rob's machine Okay, so I'm going to apply it just to this specific server, for example, and I'm going to say the source is, as I said, it's an object. It is a dynamic item. So, whoops, wrong thing. Let me do that again. I'm going to say Rob's computer. So demo desktop. So what this means is this machine will be able to connect whatever its IP address happens to be, because most environments are running DHCP. I could be on .10 today, .11 tomorrow. This will change with that. So it doesn't matter what my IP address is, as long as it's my machine, it's going to be allowed to connect. And I'm just going to put in port 3389 and add that. So demo desktop is allowed to connect to this server on this port. Okay, so as I said, it's a dynamic policy. It doesn't matter what my IP address happens to be. I have a policy now to permit RDP to that server. So let me just deploy policies here. We'll wait for, as I said, probably less than 60 seconds. And then this machine will be able to RDP to that server. Really simple, very straightforward. And as I said, it is dynamic. So it doesn't matter what my IP address is. It doesn't matter where I am. I'm still going to be able to connect to this server on this port. You can actually use it. So the idea of network control, broadly speaking, is you should get to a point of deny by default. So as you can see at the bottom of my servers group here, I do have a default deny policy. So that's what gets hit if nothing else matches. Now, you can also be more specific about this. If you are afraid of deny by default for networking, you can get really specific about certain ports. So I've created a couple of policies here. One to permit SMB, but only to trusted devices. The other to be to deny SMB, so deny file sharing to everything else.
So these are kind of template policies that can you drop on other things?
We do have what we call community policies for everything from storage control to network control. So we do have here, if we go into storage policies, you'll see we do have templated policies as well. This one actually, I'll just mention this very briefly. It was quite an interesting one. So we know about the issues that happened a couple of months ago with the blue screens. Storage control actually helped a lot of our mutual customers avoid the blue screens by ThreatLocker denying access to the problem CrowdStrike update. So basically, if we got loaded before CrowdStrike, we said nothing can access this file, including CrowdStrike. So it wasn't able to access the problem file. It wasn't able to blue screen. We have storage control policies around things like cookie access. Again, token theft is a major problem. So if we can only limit browsers to browsers' cookies, then it makes it much more difficult to steal tokens. So we have a number of policies around that. But again, your question is we do have templated policies around network control as well. But back to my demo for a second. So as I said, something like a block deny everything from accessing file share, port 139 and 445, but then specifically allowing only the machines I trust to access those ports. So you don't need to go as far as default deny everything from a network perspective. You can be very specific about certain ports. So this one is really important when it comes to remote encryption. I mean, remote encryption is a huge problem. There was a story in the media recently, in the news recently, about a camera, a network camera, CCTV camera, that was used as part of a ransomware attack. They actually got logged into the camera, ran ransomware on it, and encrypted data on a server. But again, why would that camera need to access data on a server? Fundamentally, it doesn't. Again, one of my other, excuse me, and I know favourite is a terrible word to use in this circumstance, but one of my favourite cyber attacks was one on a casino in Vegas some time ago.
It's the fish tank one?
The fish tank, a smart heater in a fish tank.
Yeah, that's a classic one.
Why does a smart heater in a fish tank need to connect to a server? It just doesn't. Now, if you want, you can do really complex network segmentation. You can buy really expensive switches and try and do all of that stuff. But realistically, we're allowing you to do it very easily, very simply from the endpoint.
Excellent. Well, if you want to know more about really simplifying, it sounds like, your whole network control process, check out what they're doing over at ThreatLocker. Their website, it's pretty easy to remember, threatlocker.com. There's the address right there. Check them out.